Okay, I'm recording on my end, so I'll post this to the YouTube uh, channel. I'm just like recording locally on my own computer, and I'm going to talk about FullStack.cash. I'm going to pull some stuff up here. Okay, I need to share my screen. Yeah, perfect. Yeah. Yes, post questions in the chat. I'll keep an eye on them. Okay, and I'm going to share my screen. Okay, first of all, can you guys hear me okay?
Yes.
Okay, cool. Cool. Okay, so what I'm going to be presenting today is FullStack.cash. So you can go to it here and you can see this nifty animation, but I'm going to scroll below the fold and just talk about... That's weird. Talk about the concept of the cache stack. And so throughout the history of computer science, it's been very helpful to think of software in terms of stacks and layers. This is how the internet was developed. You can pretty much look at any aspect of computer science and you're going to see like things broken down into layers to help just conceptualize them. And so 2 years ago, when I got back into the Bitcoin Cash space with Gabriel Cardona and Bitcoin.com, working on developer.bitcoin.com and the JavaScript libraries there, this is where the cache stack was initially conceptualized. It helped me sort of. There's different ways to do this. What I'm going to present is not the only way to do it. It's not even maybe the most common way of approaching this question of how do you write an application for a smartphone or a web page that can talk to the blockchain. So this is fairly novel, but one of its main advantages is that it's using the modern workflow. Like all web pages basically work the same way that I'm going to describe this, so it's not like a terribly unique thing. It fits in very easily with modern companies. In fact, I just had a phone call today with a company that makes a phone app, a very popular phone app, and they're trying to introduce SLP tokens into their app, and they said thank you for breaking things down and providing so much example code and documentation, which is what I'm going to cover in this presentation. So anyways, what you can see on my screen is the broken down cache stack. And so if you go to the very bottom layer, that's the full node. That's like the most basic thing that that you need in order to talk to the blockchain is a full node. And then the next layer up from the full node is an indexer. So in this example, I have ElectrumX and SLPDB. And so an indexer is like a search engine. It crawls the blockchain, it talks to the full node, the layer below it, and crawls that blockchain and builds up its own internal database. Usually address balances and UTXO information. That's typically what an indexer like ElectrumX provides, or Blockbook, or the Ninsight indexer that Bitcoin.com offers. Those are typically concerned with address balances and UTXOs lookups, because that's the most basic piece of information that a wallet needs in order to do typical wallet functions. And then, of course, there's SLPDB, which is a sort of a newer type of indexer, where it's crawling the blockchain, parsing op return transactions, and looking for SLP token information, and then creating a database of how all the tokens are connected. And that's how SLP works. It's a non-miner validated type of thing. So it actually plays on. Doesn't play at the level of the full node and the miners. It plays on the level above it in the indexer level. And then the level above that is the REST API. And I'm just gonna check So I can't see the chat. So somebody shout out really if they have a question. just kind of interrupt me, and I'll stop and answer the questions as I go. That's probably the better way to do it, since this is kind of a small informal group anyways.
Okay, this is my simple question. If you were trying to share a screen there, I just see you. I don't see screen share.
Oh, really? Is that the same for everybody else?
No, I can see your screen just fine. I'm in like a full screen mode though.
Oh, I see. Well, maybe if I click here. Wait, what is this? No, but what do I have to click, man? I screwed up somewhere.
Here, I'll stop sharing and then I'll share again. Maybe that'll fix it.
Oh wait, there. I saw your screen for a second.
Oh, okay. Let me share again. I'm sharing again. It should pop up.
Oh, now I see it. Yeah, all right.
Nice. Okay. Yeah, this is.
Because it's feeding that, and it's also feeding me like a little picture of you, right?
Right. Both.
Yeah, all right. Yep.
So yeah, Dream Trove. Do you see what I was talking about with the full node at the bottom, and then the indexers are the next layer up?
A full node. Okay. No, I don't. Yeah, I see that. But what were you saying about them?
Yeah. Okay. So this is what I call the cache stack, and what I'm working up to is that topmost layer where it says your app. That's your app, or a phone app or a web app that wants to talk to the Bitcoin Cash blockchain and interact with the blockchain in some way. And so this stack, what it's describing is a framework of how to go from your app to the blockchain. And so these are all the layers in between in this framework that of software that is needed in order to get down to the blockchain. So that's what FullStack.cash is. That's what it's based on. And so I just described the full node, and I just described the REST API, or the indexers. And so that the next layer up is the REST API, and most people are familiar with the REST API, but for those who aren't super familiar with the REST API, if you go to like Twitter.com or YouTube.com, if you watch really closely when the page loads, the first thing that loads is just a bunch of empty boxes. And that only happens for like half a second. And then those boxes immediately start getting filled in with artwork. And that's the REST API. So the web page is loading essentially a blank template that loads very quickly. And then it's making a series of REST API calls to get the content that's unique for your account. And it starts filling in all those blank things with the contents that's customized from you. So a REST API is really just a way for one computer on the internet to talk to another computer on the internet. So like a web browser to talk to a server. So that's really all it is. And yeah, go ahead, Christian. Oh, I can't hear you. Are you muted?
Are you sure it's being recorded?
I'm recording it on my end.
Okay.
Do you want to?
Okay, got it.
Yeah. Do you want to record it on Zoom?
No, it's fine because Zoom usually says, but you're using your own tool. So
yeah. I'm just using
sure.
a local tool. So that's the REST API. So that's the server side, and one of the main ideas to keep in mind with a REST API is that every programming language can talk to a REST API. So the next layer up is the JavaScript library, and that's great if you're a JavaScript developer. But if you're not a JavaScript developer, or you're not using JavaScript, you can still call the REST API. And just real quickly, I'm going to get off this theoretical stuff, and I'm going to show you guys how to just get started really quickly once I get through this stack. But I'll show you how to really quickly start playing around with the REST API here in a minute. But real quick, I'll just talk to these other two stacks. So the JavaScript library, so the REST API, we call that BCH API, and everything in this stack is open source. I'll show the GitHub repository on where to get the code for all of this stuff, and you can run your own infrastructure. But so there's the REST API, and the REST API wraps those two lower levels, and so a person only needs to learn how to interact with the REST API. they don't need to have any specialized knowledge of the indexer or the full node. I mean, it's great if you do; it gives you an advantage. But part of the reason why this stack is advantageous for developers is because it lowers the barrier to entry. You only need to learn the documentation for the REST API, and you only need to learn the documentation for BCH.js, and that's theoretically the only information you need. And I'll show how to get to that documentation. So, anyways, that's the stack, the framework of software required to get a normal modern web app or phone app to talk to the blockchain. There's other things that you can do, like gPRC is what I consider kind of like an alternative framework where you could have your app talk directly to, say, a BCHD full node, but that's not really in line with the conventional web framework. This is much more in line with the way Twitter works and the way YouTube works and the way a modern web app would work. Would use a stack very similar to this, where it would go down to a REST API, and then that REST API would wrap some whatever other technology below it, so that people can have this higher level of abstraction. So that's kind of hand wavy. Let me show you guys, since we're all developers here, let me show you guys how to get started super quick. So I did an introduction there. I introduced the cache stack. So I'm here at FullStack.cash. If you scroll down to examples, go to the examples page. Right here, this big button, view examples on GitHub. This is going to take you to the quick start examples. So you can go here, read the README, tells you how to install it, gives you some recommended initial examples to run through to sort of learn how to do basic wallet functions, how to create a wallet, how to load it with Bitcoin Cash, how to send Bitcoin Cash. But this examples repository is intended to be like Lego blocks, show you how to build really simple Lego blocks. So if you go, there's two directories here. There's low level and there's application. The low level stuff is very simple things like get details on an address, or write an op return, or read an op return, or get the UTXOs associated with an address. These are very super small building blocks. And then the applications directory has bigger building blocks, so wallet based things. So you can create a wallet, you can check the balance of the wallet, you can send BCH, you can send all the BCH in a wallet, you can work with a WIF, which is a private key. So these are very basic wallet functions, and they're broken down into very small bite-sized chunks that are easy to hack, and they all follow a very similar pattern. So once you learn the pattern, you can move very quickly from one example to another because they all use the same patterns. We have an SLP directory where we show SLP tokens, and you can even drill down into, and we've got the README kind of walks you through how to do the basics, how to create a token, mint a token, send a token, burn a token. And then I just added this NFT directory, so if you're particularly interested in non-fungible tokens, I have a YouTube video here that introduces non-fungible tokens on Bitcoin Cash, how to create them. And another tool, real quick, that I'll show you is wallet.fullstack.cash. Now this is an open alpha, and it's not quite as fully featured as, say, mint.bitcoin.com, but these are both examples of a web wallet, and they're really useful tools for if you're going to work with SLP tokens in particular, for transferring. You can create tokens using these examples and then send them to your web wallet. And Mint does not work with this web wallet. Does not work with NFT tokens, but wallet.fullstack.cash does work with NFT tokens. In case you're working with NFT tokens for the hackathon. I just added this collaborative directory. This is examples of how to build trustless collaborative transactions. Right now, there's just the one example of selling an SLP token, which is based on the swap protocol, but it's a much simpler version of what's going on in the swap protocol. That's much more complex. And then I have this directory for Bitcoin files protocol, and that's a way of writing files on chain, and so that you can share them, and that's one of the ingredients in the swap protocol. And so you can store a file of up to 10 kilobytes, I believe. But what's really handy is usually what these examples show is like JSON, like how to pass like a very small JSON object and write it on chain. So that's pretty useful for a lot of different use cases. So anyways, these are the examples. That's how to get started. That's probably the best place to start, is just to start reading through the code. Particularly, I mean, this is all JavaScript, so that really only helps JavaScript. If you're not a JavaScript programmer, let me show you also on the examples page, there is this Explorer UI, and you can go to the Explorer UI, and there's a drop down here. You can switch between mainnet and testnet. And this is the REST API. So if we go back to the cache stack, what I just showed was examples using the JavaScript NPM library. But if you're not using JavaScript, ooh, what happened to my light? Oh well. If you're not using JavaScript, the REST API is what you'll want to use if you're not using JavaScript. And so this Explorer will show you how to very quickly get started with the REST API. So there's ElectrumX is an indexer. Blockbook is also an indexer. Blockchain is REST API calls that are concerned with the blockchain, so you can get like the block height. This get TX out is really handy for validating UTXOs before you spend them. You can just get information on the blockchain, like the block height and the difficulty. So anyways, that's what those are for. Control is getting basic info on the node. There's some basic encryption tools. This is how you can look up someone's public key. If you have someone's Bitcoin Cash address and they've made a transaction to the blockchain, you can use this endpoint to pull their public key from the blockchain so that you can encrypt a message and send it to them. Basic information on mining. The raw transactions. This is how you actually would broadcast a transaction. You'd use this send raw transaction. This will actually, if you have a hex encoded transaction, this is how you broadcast it to the network. And then these are really useful tools for working with transactions, decoding them, like for debugging purposes. If you're getting some weird like code 66 error or something from the full node and you're trying to figure out what's wrong with your transaction, you can load it into decode raw transaction. You can throw the hex in here and it'll well, let me just show you. So that's like a hex encoded transaction, and it breaks it down into a JSON object. So you can see the inputs, you can see the outputs, and you can see the script signatures, and like basically everything you would want in order to like debug a transaction that you think should be working and it's not working. And then there's this SLP endpoint, so that like this is a handy one that lets you convert addresses. So if you have a Bitcoin Cash address and you want to know what its corresponding legacy address or SLP address is, you can do this, so it'll break an address into its 3 different representations. And you can check like the SLP balances for an address. You can look up statistics on a token, like see how many are in circulation, how many have been burned. You can validate a transaction. This is for generating like a send, a very standard send op return for SLP tokens. So there's a lot here that, and because it's a REST API, you can talk to it from any programming language. And so let me show you guys. That was probably pretty overwhelming with detail. Let me show you where to get the documentation. If you go to FullStack.cash, right next to the examples button is the documentation button. And I'm going to turn on this light because it's getting dark up here. There you go. Now my camera doesn't have to work so hard. So if you go to the documentation page, there, right here, you can click on BCH API. That's the REST API. So this is the documentation for all those endpoints I just showed you in the Explorer. You can get more details on them, what they do, what sort of inputs they take, what sort of outputs they give you. If you're using the JavaScript library, this is the documentation for the JavaScript library. It wraps the REST API. So if you use the JavaScript library, you have everything that I just showed you for the REST API, plus you have tools like how to generate an HD wallet, how to like sign messages and verify signed messages. So a lot of like more stuff comes in baked into that JavaScript library, and this is based on Bitbox, which was originally I helped develop it, developer.bitcoin.com. And finally, I want to show you guys the cache stack. And so I showed you guys how to get started really quickly. I showed you where to go to get documentation. If you find a particular example that you want to drill down into. But now I want to zoom way out and talk about the cache stack and like sort of more of how do you orient yourself to the Bitcoin Cash developer ecosystem in general. And how do you gauge? If you talk to other developers who've been in this space for a while, they're not all sold on the cache stack as like the best way to approach this problem of building web apps and phone apps. And so that's what this article talks about. And I just clicked on the cache stack button here in the documentation page, and this takes you to my blog. And so this is like a body of work that I wrote after being in the space for a couple years. It's got references to a couple of my YouTube videos. This one at the top like actually just walks through this whole article because it's pretty long. But it talks to sort of how the cache stack came about, alternative ways of approaching web apps if you don't think the cache stack is a good fit for you. It talks about all the different full nodes in the space, all the different indexers in the space, because you don't necessarily need to use the ones that I picked out for the cache stack. You can use alternative full nodes. You can use alternative indexers. You can use there's really only one. Well, there's two different SLP indexers. There's one by Bitcoin.com and there's one by there's SLPDB by James Kramer. There's other JavaScript libraries. There's other REST APIs. So in this article, I tried to capture like basically the entire tool set industry that exists. It's pretty small. It all fits in one article, and so I tried to kind of just encompass everything. So if you're not sold on the cache stack, this is how to like evaluate the other options. After going on 3 years in this industry, I feel pretty confident about the cache stack. I'm getting feedback from businesses that it resonates with them, especially if they have experience building web apps and phone apps. It follows a very common framework. What else? I thought there was one other thing I wanted to cover with you guys. And so this is not specific to the hackathon, but it is specific to Bitcoin Cash in general. If you go to the navigation menu on any page at FullStack.cash, if you go to the navigation menu, there is this cache strap page, and if you click there, you can see all the infrastructure that goes into the cache stack. So I've got I run on Bitcoin ABC, but in October I'll fire up a redundant cache stack using BCHN, so that after the fork, users can switch back and forth between chains with just one one line of code change in BCH.js will let you switch between chains. And so there's the full node. This is Blockbook, which is an indexer. I'm sort of phasing that out in favor of Fulcrum, and which is another indexer, and then SLPDB. So what I don't want to do with FullStack.cash is create a walled garden. I don't want to make everybody use my service and you can't use anything else and lock you in, because that's not that's antithetical to Bitcoin. Bitcoin's all about open source. It's all about permissionlessness. And so what I do on this the cache strap page, it's like a play on the word bootstrap, is I have Docker containers and pre-synced databases that those Docker containers can mount. So instead of having to wait like 2 weeks for your full node to sync from Genesis, and then wait for your indexer to sync from Genesis on top of your synced full node, and run multiple indexers trying to do that, which is literally weeks of computational time. You can just download a pre-synced database, mount it with the Docker container, and you can have a whole stack, like the same infrastructure that I run at FullStack.cash. You can have that up and running in a day, assuming you have the prerequisite technical knowledge. Now, most people don't have that knowledge, and that's why I charge money for what I do. But if you want the self-sovereignty of running your own infrastructure, everything's here for you to download. Nothing costs any money, and I've tried to make it as easy as I possibly can for everyone to get started developing in Bitcoin Cash on their own terms. So I think that's pretty much the presentation. I'm hearing crickets. Any questions?
Hey Chris, I got a question.
Yeah.
Can you go over the pricing for using all of the endpoints?
Yeah, so it's actually I had a more like complex pricing setup, but I got a lot of pushback on it, so I have a very simple pricing. It's either free or it costs $30 a month. And so the free tier you can get, which is what the examples, they use the free tier by default. So if you go look at those BCH.js examples, you can see how to use the free tier by default. In the dev questions, I put some examples of how to call the REST API using the free tier. And the free tier allows up to 30 requests per minute. And so if you get stopped out, just put an artificial, like, that's 2 seconds. So put an artificial, like, 2 second delay between API calls, and you shouldn't get stopped out. And that should be adequate for many applications, and including hackathon prototypes. The paid tier is 100 requests per minute, and that doesn't sound like, for a lot of people, that doesn't sound like worth paying $30 a month for. But the thing is as the free tier gets more and more popular, it's going to get more and more bogged down, and it's going to get slower and slower. Whereas the paid tier is going to scale proportionately to the number of people paying. So it'll feel, even though it's shared, it'll feel like. So that's how that price is going to pan out. It's not just quantity; it's quality, and it'll be more obvious with time and popularity. But for now, the free tier is not being used very heavily, and I encourage everybody to use it. You don't need to pay for the service. It's really for businesses that that are trying to do business and need reliable service. And just today I was talking to that app company, and I was having this conversation with them, and I was saying the same thing. Like, just use the free tier, use mainnet or testnet. I have testnet as well, but mainnet is usually you develop on mainnet in Bitcoin Cash because testnet's weird. Anyways, you only need to start paying for the paid tier if you really need it for your business. But they were concerned with having a real path towards scaling, like for millions of users a day type of thing. And so I do offer isolated infrastructure. So that's like the ultimate enterprise, where I will spin up an isolated infrastructure for your company, and then we can scale further beyond that. This is just the entry level enterprise, type of thing. So that's how I have the pricing scheduled. And the big takeaway from that's a long-winded way of saying that if you're in the hackathon and you're a hobby developer, don't pay for this. You don't need to.
Okay, great, thanks. And how does it work for client-side applications? What's the core like for the endpoint?
Yeah, so I'm not sure if I totally understand the question, but the idea is like this would be the client. The client would be the topmost layer on that stack, and like wallet.fullstack.cash, that's an example of a client wallet. So it's considered like non-custodial because the wallet itself exists in your web browser. The server doesn't have any access to any of this. It's just making API calls using the JavaScript library. Does that answer your question, or I feel like maybe I didn't answer it very well?
Yeah, so if you were on a different domain, they can call it to the API endpoint. So what's the cross-origin resource policy?
It's open. Yeah, I have
Okay.
it's open to everything.
Got it.
Yeah, I let the rate limit because there's no sensitive information that that you can pass. It's totally fine to like clear text a Bitcoin Cash transaction, right? Because that Bitcoin protocol takes care of that. So there's nothing that's sensitive in nature to this REST API. The sensitive things like the keys for the wallet, that's what would be contained client side, like in your web browser in local storage. Yeah, so I don't know. Hopefully that answers the question.
Yeah, it does. But when you're working with the free tier, how do you monitor sturdy requests when it's coming in from different same domain but different users and different IP address?
Right. Yeah, it uses the IP address. So it just basically is looking at the IP address and saying, and then it's key. There's a rate limiter that says, okay, this IP address is only allowed to do 30 requests a minute, and so it just throttles based on that.
Right. So if we were developing an app, and all the clients are making their own requests, so it's 30 requests per minute per user.
It would be. Right. So, like for example, wallet.FullStack.cash, it's using the IP address. So it's using my IP address of my computer to track that rate limiting. And then specifically for wallet.FullStack.cash, I have that domain whitelisted. So you won't, as long as you're using wallet.FullStack.cash, you won't hit rate limits. But if you were to say fork this and put it on a different domain, then you'd be subject to the free tier rate limits, if that makes sense.
Yeah, but it's per user. Okay, that's good to know. Thanks.
Yeah. Okay, well, cool. I mean, hopefully that gives you guys something to think about. It's a lot of information, but I encourage you as you develop your projects to think in this regard, because this is basically considered best practices and standard architecture for web apps and phone apps these days. You're going to have a REST API somewhere. Pretty much the entire internet runs on REST APIs. What's behind the REST API, is custom. And then in the case of like modern web tech, you would have a client-side JavaScript library, which is what BCH.js is, and or if it was a different programming language, you'd have you'd still have a library just for that programming language. So looking at this architecture, look at your application, and think about how it fits into all of this. What features you need in terms of accessing the blockchain, like SLP tokens. Do you need to sign messages? Do you need to generate a wallet? If you can like isolate those types of requirements, then you can start to like look through the documentation and the examples and pull out the little building blocks that you're going to need to build your application for the hackathon.
I'm just curious, is there a max SLP tokens one can generate? Like,
yes and no. There is like a numerical limit. I think it's like above 1 trillion. But if you were to hit that limit, as long as you have a minting baton, you can just mint more. So it's really just a limit on how many you can generate in the Genesis transaction, and as long as you have the minting baton, you can just keep minting as many tokens as you want.
and I'm just curious, do you follow the development of member.cash much at all, or you sort of everything that you do.
Yeah, I'm in communication with Free Trade. They actually have an end-to-end encrypted messaging system, and that's based on my code.
Okay, nice.
Yeah.
Thanks for all you do.
All right. Well, I think that's the Oh yeah, go ahead, Christian.
Yeah, my question is, how is the REST API functionally different from the NPM library? Is there some overlap?
That there is. So the JavaScript library talks to the REST API. You can talk to the REST API from a different programming language, but if you use the JavaScript library, you don't need to worry about the REST API because everything the REST API can do is in the JavaScript library. But the JavaScript library has a bunch of extra tools like generating HD wallets and working with HD wallets, and signing and reading messages, just like generic cryptography and generic like transaction stuff. Like that's really the client side part of it. That generates private keys and secrets and stuff like that. So there's a lot more tools in the JavaScript library than what's just available with the REST API. And I'm glad you asked that because something that can help kind of bring this home. And another good tool that I did not share is on the examples page. Another one of these examples is this SLP Wallet Library. This is SLP Wallet. And it's a command line. Oop, what did I just do? Can you guys still see my screen?
Yes.
Okay, you can still see my screen? Okay, good. So this is the GitHub repository, and for SLP Wallet. It's an NPM library, but it's not really... the first time you use it, you should just git clone it, and there's instructions on how to install this dev environment, and this is like, so if you go through the BCH.js examples and you get comfortable with the wallet functionality in there, creating a wallet, sending BCH, checking balances, and you get really comfortable with that code, this is the next step up. This is all those examples put into one command line application. Because it's a command line application, there's no graphical user interface, and you can move much faster. You can prototype much faster without having to worry about the graphical user interface. And that's the main value here. Is it's a rapid prototyping tool, and but just right out of the box, you've got full HD support, like sort of privacy centric. When you create a wallet, if any of you ever get into, I've actually created 3 wallets in my career so far. And when you create a wallet, one of the big problems you have to wrestle with is UTXOs. And how do you efficiently spend UTXOs? And so, for example, wallet.FullStack.cash is not privacy-centric. It's optimized for minimizing the number of UTXOs in order to minimize the number of API calls and make the wallet fast. Whereas SLP Wallet is privacy focused, so it's not trying to minimize UTXOs, it's trying to minimize address reuse, which is usually a thing that an HD wallet tries to achieve. And so some of these nuances and trade-offs are good to keep in mind. But anyways, out of the box, this command line wallet, it's JavaScript based, it's all open source. Every command is broken out into its own file that you can dig into. So like you can create a wallet, you can list the wallets, you can check your balances, get new addresses off of the HD wallet, you can sign a message, you can sweep Bitcoin Cash off of a paper wallet, and it also works for sweeping tokens, so that the code that's in Badger Wallet that we were playing with earlier that lets you sweep SLP tokens off of a paper wallet, that was based off of this code. So that's all in there. And I think during the hackathon tomorrow, while everybody's working on their projects, I'm actually going to fork this, and I've been working on a new CoinJoin protocol. So I'm going to try and fork this wallet and turn it into a CoinJoin wallet where you can deposit some Bitcoin Cash and let it sort of churn away with other players. But anyway, so you can play with it as a standalone command line app. You can hack the heck out of it. It's perfect for a hackathon. And then if you're building like a more sophisticated app with, say, a GUI, it is an NPM library, so you can just drop it into your application and have access to all of those commands, and you get an HD wallet. Your application has an HD wallet that works with SLP tokens right out of the gate. So I strongly encourage this. This does not get enough eyeballs. This is one of my go-to tools. It's one this is what I use for rapid prototyping new ideas. It's perfect for a hackathon, and very few people use it. And it's because it's kind of overwhelming. There's a lot there, but if depending on what you guys are building for the hackathon, that might be your fastest route to building a prototype.
Hey Chris, is there documentation on how many calls to the API per function there are?
Oh, not really, because
no way to track it.
There is actually. I mean, like, so if there's, like, for instance, wallet.FullStack.cash, which is also open source, and I'll show you guys the source code for that. So with the exception of SLP Client Wallet that I just showed you guys, all the source code is in the Permissionless Software Foundation GitHub repository. So BCH, so the BCH.js examples, BCH.js, which is the JavaScript library, BCH API, which is the REST API, all that source code's here. And so you were asking how to track. So if you, like in a browser, when you have a GUI, you can just open this up, go to your network tab, and then.
Can I share your screen?
Oh yeah, thank you. So yeah, okay. I was trying to point this out earlier. So this is the Permissionless Software Foundation GitHub repository, and so for instance, the BCH.js examples live here. The BCH.js JavaScript library lives here. The BCH API REST API lives here. And then you were asking about how to track calls. So, for instance, in the web wallet, you can go to... this is Brave. Chrome works the same way. Firefox is almost identical. There's this More Tools in the menu, and you can go to Developer Tools and go to the Network tab. And then when you go to... so I navigate back to the tokens directory, you can see the API calls that it makes. So I've got 4 different classes of tokens, and it called hydrate UTXOs twice, and it queried the balance on this address twice. So it made 4 API calls to load that page. So if you're working with a GUI, that's a really fast way to track your API calls. If you're working like in the BCH.js examples, it's not quite so easy as that to track it. But most of these, particularly if you're just getting started with some of the basic wallet functionality, most of these examples will just use one API call. And you can tell which one it is if you turn your Wi-Fi off and then run the example, and it'll error out. And the line it errors out on is because it was trying to make a network call and your Wi-Fi was turned off. That's probably the easiest way to identify them. So yeah, I wish there was an easier way to do it in the command line or on Node.js as there is in the browser.
Yeah, so the DevTools is definitely a useful resource for the network, watching the network calls. So is there not a way to programmatically track the calls, or are all the calls, is it always the same amount of calls when you're using one of the BCH.js functions?
Yeah, that's the thing. So if you're building something like a wallet, you're going to do the same thing over and over again, and every time that thing's going to do the same thing, it's going to make the same number of API calls. So you once you start using BCH.js, you'll just get a natural feel for what's built into the... Basically, anytime it interacts with the blockchain, it has to make an API call. If it's doing something like creating a wallet or generating an address or signing a message, those don't actually interact with the blockchain. They're just more like basic cryptographic methods that aren't specific to Bitcoin, and they happen locally. They don't need a network connection for that. So it's usually when you interact with the blockchain, like look up the balance of an address, or retrieve the UTXOs associated with an address, or look up information on an SLP token. That's when it's going to make API calls. So then the more you do it, the more you'll just get a natural sense of what is an API call and what's not.
Okay, but if there was a function that was to check like all the UTXOs, it would vary per wallet, right? Or is it always the same?
Yeah, it would. On a per wallet basis, it would vary. Within one wallet, it would be like you'd be doing the same thing over and over again. To drill down into that, though, specifically to FullStack.cash, we followed the same paradigm that I helped create at Bitcoin.com with Bitbox and Rest.Bitcoin.com. Is there's get calls and there's post calls, and generally like the get calls they work really well in a web browser, and you query like say the balance on one address. But in a post call you can put in like 20 elements, so you could query like 20 addresses at a time, and so that significantly reduces the number of API calls you need to make, because you can say get the UTXOs associated with 20 different addresses with just one call.
Okay, great. Thank you.
Cool. I'm just checking the chat. Yeah, okay.
Another question I have is the npm libraries JS. Are they their own full node, or do they query your API server?
They query the API server. So yeah, they're not self-contained in that way. The only thing that's really self-contained by the JavaScript library is like the ability to create HD wallets. So one of the things that a lot of people don't like, I didn't really get this until I thought about it for a while, but like with an HD wallet, if you follow the examples to create a wallet, you can generate like billions of addresses in one HD wallet. But just because you generated the address doesn't mean anything happened on the blockchain. Nothing happens on the blockchain until you actually like send or receive Bitcoin Cash at that address. And so that's like one way to think about that is like you can generate as many addresses as you want, and it just happens locally on your computer until you interact with the blockchain by sending or receiving or querying data on an address.
Got it.
Yeah, and so ultimately, the JavaScript library is calling the REST API, and the REST API is interacting with the full node on the server. And thanks to HD wallets, that's all secure. Like just because you're using my full node or you're using Bitcoin.com's full node, I can't in any way jeopardize your security because of the way HD wallets and Bitcoin Cash transactions work. That's all local to you, and all I'm doing is essentially broadcasting the transaction for you. Okay, well, I'm not hearing any more questions. So let me wrap this up with, I put a note in the Dev Questions Discord channel, but anybody who wants to use FullStack.cash, first of all, I encourage you to just use the free tier, because you won't have to worry about a JOT token. If you can make that work for your prototype, do that. If you need increased rate limits, you can go to, there's a pinned message in that channel, and there's a contact form at FullStack.cash. You can fill that out with the email that you used to create the account, and I'll credit the account so you can get a month of free access at the increased rate limits of 100 requests per minute. stop recording.